Okay, welcome back to Foundations Math 20. This is section 5.6 in your textbook on confidence intervals. This will be a real quick section today. All right, so using normal distribution to solve problems that involve confidence intervals. So a lot of times it's not practical to survey every single person in a population, right? You can't go around knocking on all the doors. You can't even go in their house right now because everybody's under quarantine. If a light bulb company wanted to test the number of hours that a light bulb will burn before failing, again, it's not going to test every single bulb that it makes. Right? What is it going to do? Well, it's going to take a sample of them, test those bulbs, and figure out the longevity of its light bulbs using confidence intervals. Right? So, what is a confidence interval? Right? Margin of error. So, the possible difference between the estimate of the value you're trying to determine, as determined from a random sample, and the true value for the population. A margin of error is generally expressed as a plus or minus number, so plus or minus 5%, right? So if I tell you that these light bulbs will last, this brand of light bulbs will last 108 hours, plus or minus 5%. Well, that means some of them will last a little less than 108, some will last a little bit more than 108 hours, yeah? Plus or minus 5% of that. So 108 times 5%, right? Add that to the 108. 108 times 5%, subtract that from the 108, yeah? What else do you need to know? Confidence interval. The interval in which the true value you're trying to determine is estimated to lie with a stated degree of possibility. The confidence interval will be expressed using plus or negative notation. So 54% plus or minus 3.5%, or in other words, ranging from 50.5%, that's 54 plus minus 3.5, and 54 plus 3.5 to 57.5%. Right? So this is my confidence interval. This plus or minus, right? That's your margin of error. So when you're looking for questions that say, what's your margin of error? Look for the plus or minus sign in the question. Right? If you're looking for the interval, then take your mean, your average, right? Your mean amount, and add the percentage, subtract the percentage. That then gives me the interval. Yeah? All right, let's go down to the next thing. Confidence level. The likelihood that as a result for the true population lies within the range of the confidence interval. So surveys and other studies usually use a confidence level of 95%, right? Although some of them 90%, some of them 99% are sometimes used, right? They see on TV all these commercials, right? 2 out of 3 doctors recommend, right? What is 2 out of 3 doctors as a percent? 2 out of 3. 66%. Wow, that's not really a very good doctor recommended. How about 9 out of 10 doctors? 90%. Oh, okay, well that's a little, I feel a little bit more confident that it's 90% rather than 2 out of 3 or 66%. Right? So people say, oh, 2 out of 3, that sounds pretty good, right? It's only 66%. Right? I want the 2.5 doctors. You know, I want 90%. Right? I would prefer 95%. Right? But 90% is a pretty good number. Right? Anything below that, I'm not very confident in that survey. Right? So it's a good way of assessing the things that you're hearing on the news. Right? They give you statistical information about the percent of people that are at risk to the coronavirus, plus or minus a certain number. Right? There's your margin of error. Right? I can figure out the confidence interval. Right? With a confidence level of 66%, well, yeah, that's a number very confident in those scientists. Right? I want to know probably 95% maybe. Right? 99 would be even better, but we'll take what we can. 90%, okay. If I have to, I'll write, I guess. All right. So let's look at a question here. How does this relate to what we're looking at? So a poll determined that 58% of people living in Canada know the cost of living for the average Inuit is 50% higher than the cost of living for other Canadians. So notice that in this question, like a lot of the questions you're going to get, there's going to be a couple different percent symbols in our question, right? Those are there as red herrings to trick you to make sure you pick the right one, right? So a poll determined that 58% of the people know the cost of living. I don't even care what it is, because that's what this other one is. It's a red herring, right? So, what percent of people know this? Well, 58% of people know this. Okay, great. 58% of people. The results of the survey are considered accurate within plus or minus 3.1%. Right? I'll go ahead and circle these things, put the squares around them. Right? 19 out of 20 times. Yeah? So, confidence level. How confident are they? That's so many out of so many, right? So, 19 out of 20 times. What is that as a percent? Well, 19 divided by 20. I don't know what my calculator's on there. Divided by 20 times 100, 95%. Is that a pretty good poll? I think I can be reasonably confident in the information they're telling me. That, 58% of people is pretty accurate. Right? What is the confidence interval? Well, 58% plus 3.1%, 58% minus 3.1%. Right? So 61.1% and 55 point.
No,
55.9%. All right. So somewhere between 55.9% and 61%. So about 56 to 61% of Canadians know this statistic. All right. The population of Canada was 33.5 million at the time of the survey. What is the range of the number of people who knew the cost of living for the Inuit is higher than the others? Well, we're going to take 61.1% times 33.5 million, right? And 55.9% times 33.5 million, right?
I think it's actually 54.9.
How much?
54.
54.9? Oh, okay. 54.9. Okay, sure, whatever it is. All right, let's pull this out. We'll find out what it is. Yeah, if it is 54.9. Let's move that down a little bit. Nope, let's slide it over here. Maybe. Get it over there. There we go. Oh yeah, 54.9 to 61. Let's move that up a little. A little bit more. We'll go a little more. Keep going, keep going, keep going. There we go. So, 18.4 million to 20.5 million people knew this.
Right.
Make sense? All right. So, then you're going to get tested on this. Really, what are they going to have to say? What's the margin of error? Okay, look for your plus or minus sign. Confidence level. So many out of so many. Right. Confidence interval. Well, that's the whatever the percentage is plus that number minus that margin of error. That's really it. That's all you have to do. All right. One more question. We'll finish this off. All right. Nope, that's not the one. Next one. Was there a backup one? There we go. Oh yeah, the baseball one there. All right. Let's load that page. All right, there it is. Okay. So, big long question. So, to meet regulation standards, right? Baseballs have to have a mass of 142 to 149 grams. If they don't, they're, playing with the wrong balls. right? Manufacturing company sets its equipment, makes these balls with a mean mass of 145 grams. That's our mean mass, yeah? So they test their equipment every so often, make sure that, it's making the right kind of baseballs, all right? If the mass of the random sample is 144.7 to 145.3, they go, yep, our equipment's running pretty good, yeah? So if the mass of the sample is outside of the acceptable level, then they have to shut everything down and recalibrate the machines, whatever, and then start it up again and do another test, right? So, what is the confidence interval and margin of error that an engineer is using for control tests? Wow. We know that the mean is 145, yes? And they're saying, okay, it's okay if it's 144.7 and 100 to 145.3. That sounds like an interval, yeah? So an interval of what? Well, that means that if we look at 145 as our mean and 145.3 as one end of the spectrum and 144.7 as the other end of our spectrum, right? That means that our plus or minus area is 145 minus 144.7 or 145.3 minus 145, 0.3 grams, 0.3 grams. This is our plus or minus margin of error, plus or minus 0.3 grams, right? Our confidence interval, 144.7, 145.3, yeah? Let's look at this. Does that make sense? Okay. So, if they want to have confidence in their testing, all right? If they want to have 99% confidence, they need to test 110 balls. If they want to have 95%, they need to test 65 balls. If they want to have 90%, they have to test 45 balls, right? What do you notice about this?
It goes down like the same amount each time. Isn't it?
No. What is the relationship between the confidence level and the sample size? Well, how many balls do we need for 90% to be 90% confident? 45 of them, yeah? To be 99%, we need to test 110. That's a lot more balls, yeah?
Oh, yeah.
That's like more than double.
Yeah.
So, as we go from 90% up in terms of confidence, we need to test more balls, yeah?
Mhm.
Okay? So, let's go to our summary page. Nope, the next one, last one. Right? So, here's what this means, right? So, let's suppose that the sample size, or sort of, what I'm trying to say is that the sample size affects your margin of error, right? The larger the sample, the better the margin of, the smaller the margin of error, right? Because we're testing more balls, so we're going to be better able to, we're going to be closer to our 145 mean, right? So a sample of 1,000, for example, is considered to be accurate between plus or minus 3.1. 19 out of 20 times. Right? What's 19 out of 20?
95%.
95%. If we test 2,000 items, it will be accurate within plus or minus 2.2%. If we test 3,000, plus or minus 1.8%. So the more people we ask, the smaller our margin of error, right? So for example, if I go outside and knock on 5 houses and go, do you guys have the coronavirus? Anybody in here have the coronavirus? Anybody in here have the coronavirus? Right? It might be plus or minus 15%. If I go and ask 25 houses, it might be plus or minus 10%. If I go and ask 1,000 houses, plus or minus 3%. Right? So the larger the sample, the more accurate the results we get. Right? If you ask all the kids in your school who likes rock music, but you only ask 3 kids, right? You might go and ask the wrong 3 kids and go, yeah, I don't like rock. Nobody likes rock music in this school, apparently. Right? No, you just only asked 3 kids who don't listen to music. I don't know. 3 weirdos. But if you ask 100 of those students out of, say, a school has, I don't know, 300 students, right? 100 out of 300, right? Is that enough? Right. Well, yeah, that's a third, right? So what do you want? Well, you want to ask about, you want to always have a sample size that's going to give you a confidence of about 90% minimum. Anything lower than that, I can't really trust the source. Yeah, I need more data. Make sense? So, 19 out of 20, that's our confidence level. Plus or minus, that'll be our margin of error. And then our interval will be whatever the number is, plus that number and minus that number. Yeah? Questions?
No.
Well, that's the end of the unit. I'll give you some questions to try. So you can look at page 274. And you can do questions 1, 3, 4, 6, 9, and 10 if you want some practice on this. But to be honest, you're not going to get tested really a lot of, a couple questions on this. What's the margin of error? What's the confidence level? What's the confidence interval? Right? And be careful, you're going to get some of those red herring questions. Right? Different percents, got to make sure you pull out the right one. Read the questions carefully. Yeah? Anything else you want to add?
No.
All right. That's it for Foundations Math 20, Chapter 5. We'll maybe see you back for the next unit. Might be Chapter 6, I'm not sure, I'll have to look. But we'll see how things go with school and everything else. Enjoy.